Hey everyone, welcome to today's webinar. My name is Julia Heeson, and I'll be your host for the next 60 minutes as we explore the critical topic of ensuring reliability in research. We'll wait just another minute or two for people to actually join in, so feel free to go ahead and grab yourself a cup of coffee if you want. But while we wait, Sharon, why don't you share what we mean, on the slide as we say we're here today to stargaze the future of reliable research.
Thanks, Julia. My name is Sharon. I've been in STM publishing for quite a while now. For nearly 2 decades, I worked at a Swiss publisher to build out their dissemination channels and extend the reach of their published content. As we see the publishing industry evolving and research practices evolving, we notice that there's a very clear need for reliable research. Different challenges such as AI and paper mills and additional sheer volume of research output have made it difficult to reproduce research and bring it to the level of reliability that we need to bring science forward. So we're going to be discussing some of the challenges today, as well as some of the solutions. So we're so happy to have so many people joining us. We have over 400 people who've signed up to listen in today.
Certainly. Okay, and I see many of those people have joined. So if you just joined, welcome to this webinar. Before we get started, a couple of housekeeping items. So you're all in listen-in mode. You don't have to worry about background noise whatsoever. We do have the chat enabled. So if you have more of a technical question, feel free to add that in the chat. I'll be monitoring that. We do also have the Q&A enabled. So down on Zoom where it says Q&A, feel free to click there and add your questions as soon as they come up. But also know that towards the end of the webinar, we'll have time saved to answer your questions. And then this webinar is being recorded, so I'll be sending the recording to all of you. You don't have to worry about that. If you want to rewatch it, share it with colleagues. I'll be sending the copy of the webinar probably an hour or two after the webinar is over. Okay, Sharon mentioned a little bit about this already, but what are we here to talk about today? Just after this slide, we'll be introducing today's panel. You see the panels on this call, so of course it's important for all of you to know why we have this panel of experts here and the unique perspective that they bring to this topic and the webinar today. Then from there, we'll be discussing the challenges facing modern research, challenges that the panelists here face, that we know researchers and the research community is facing, as well as tools, technology to identify, filter those unreliable studies, what proper data management looks like, and how that helps mitigate risk and other best practices in scientific publishing. And then from there, really the heart of this webinar will be the fireside chat. So that's where we will be focusing on. We'll be discussing, for example, AI, what is trust in research, what is zero trust in research, and do more of that stargazing that we already mentioned. And then as I mentioned, we'll be happy to answer any and all of your questions if we don't already answer them throughout the first part of the webinars. Okay, with that being said, Adrian, over to you.
Thank you. Yeah, so excited to be here. Adrian Stanley, working as an independent consultant for many, many years in scholarly communications. So excited to be moderator-in-chief with Sharon, a good friend, but actually equally excited to be working with these sort of panelists here. I'm going to do a very brief introduction, but really hand over to them to give context of where they're coming from, what they're doing in the daily work, just to give you context here so that then we can really kind of begin to look forward and some of the implications and perspectives of where AI and reliable research is heading. So first up, we have Adam Day, who's the founder and CEO of Clear Skies, one of the sort of premier paper mill alerts that really detects research fraud, works across a whole range of publishers. Tim Vines is the founder and CEO of DataSeer. I'll let Tim kind of explain what he does, but really kind of helping uncover, working with funders, publishers, and institutions where data sets should be shared, how to be compliant to mandates, and really uncovering ways where research excellence and transparency can be done. And then finally, Sean Reif, still an assistant professor at psychology at Murray State, but also the head of academic relations at Research Solutions and one of the sort of co-founders of Scite, the product. The interesting thing about all these three here, they've all come from a research background, different types of research, have sort of worked in innovation technologies, and are really then bringing their learning. We've had some great preparation chats, so I'm so excited for you guys to kind of be part of this. We encourage you to share questions, share thoughts, share comments. We hope to inspire you, to make you think, to challenge you. So on that note, Sharon, I think you have a couple more slides, right, of just framing this, but let's get on to sort of talking with these guys too.
Sure. Yeah. Thanks, Adrian. I introduced myself at the very beginning, but my name is Sharon. I've been at Research Solutions now for just over 8 years. And prior to that, I was at a Swiss-based publisher. I've been curating publisher relationships at Research Solutions for nearly 10 years now to help improve discoverability and distribution of research output on behalf of publishers. And the research process, being as it is, the challenge of reproducibility is the tip of the iceberg as well as the root of the problem. We can move on to perhaps the next slide. The amount of research that is being published year over year is increasing exponentially. So it becomes very difficult to sort through everything and make sense and to find the needle in the haystack, so to speak. And then we can move on to the next slide. Companies spend millions of dollars a year on drug development and therapies. Reproducibility of research is core in being able to support their product development as well as their initiatives. Without being able to replicate research results, time, effort, and focus, as well as dollars are wasted, and the ultimate goal of moving science forward remains elusive. Now, today, we can go to the next slide. Today, when we are going to discuss these main challenges, there could be a great many more, but we're going to focus in on these 5 today. AI tools, they put research integrity at risk. The information overload, fragmented access from various researchers and research communities, and the varying quality of output and lack of reproducibility, as well as the very real and explosive problem of paper mills contributing not only to content overload, but also eroding public trust. So I am going to introduce Adam right now to begin talking about what he's done in his work at Clear Skies.
Thank you, Sharon, and thank you for having me here. So Clear Skies is a data analytics company, and we were founded to support science and particularly the peer review process, the peer review system. And as Adrian said, we created the first paper mill detection service. That's a service called the Paper Mill Alarm. One of the things that we do is network analysis, and actually that's what we're looking at in this slide here. Network analysis is about understanding the connections between things, and it's kind of a fundamental cornerstone of fraud detection. Any industry you look at, fraud detection is often built on network analysis. One of the really nice things about it is that you can kind of amplify the features that are already there. So what we're looking at here is actually authors, and the lines that you're seeing there are connections between authors telling us that they have co-authored on papers. Now, this is interesting because the red ones, those are the naughty ones. Those are papers that something bad was done on those. And what's interesting about this image is that this shows us a community of people who we know work together, and we know that the rate of those problematic papers is quite high. So actually, the whole community is worth looking into in a bit more detail, given that we see this very high rate of this problem. And the network analysis helps us to see that. One of the really incredible things about this industry, this field, is that we have always built network data, even before people were even doing network analysis, because we have things like the practice of referencing and citation, which creates networks. It creates networks of connections between research outputs, and that has existed for centuries. It's existed longer than a lot of the analytical methods that exist to work with that kind of data. So we're incredibly lucky to have that built into our system, and it actually makes my job doing this kind of analysis and detecting these problems that much easier. So yeah, quick intro to Clear Skies.
Yeah, thanks, Adam. Yeah, thanks for having me here. So what DataSeer does is we are automating tools for looking at open science practices by researchers within the context of their articles. And we use natural language processing to uncover what authors have done around sharing their data. And we feel this is really important because a lot of the research access extends from bad to great. And researchers along the way are taking a wide range of approaches to how they do their research. On the left-hand end here, they are sort of being fraudulent. They are cheating. They are not doing the research they're actually saying they're doing. They're manipulating the peer review process to get bad research into journals. So these people really need to be stopped and kept out of the process. But to the right of that, there are actually many, many other researchers, and the community needs to understand where a piece of research lies at any point along this axis, especially if you're trying to, as a pharma company, trying to decide where to put research effort, how much to trust a result. Not knowing whether it's fraudulent research or not is really useful, but knowing whether it's great research versus decent is also really important. So if you can trip on to the next slide. These researchers spread themselves out. So the cheats are there on the left, and they avoid the sunlight of open research at all costs, because the more of their outputs they expose, the more likely they are to be caught. For example, Jonathan Pruitt, who made up a lot of research about jumping spiders, was caught because the journal American Naturalist made him share his data sets. And then once people looked into his data sets a bit more, they could see that it had all been fabricated. And so open science is an anathema to researchers who are cheating on what they're doing. And also it's a pain for them. They just want to churn out articles from the paper mills as fast as possible. Having to produce code and data sets to go along with those articles is annoying. It's an extra cost. Making that all join up is extra difficult and undermines their bottom line. And in the middle here, there are researchers who are focused on the tenure track wheel. They just want to publish as fast as possible, and they don't really, they're under a huge amount of time pressure. They're under pressure to get papers out, to get grants. So they're not really engaging in the purpose of the scientific process. They are working on their careers as a scientist. And so they are willing to take shortcuts to open research, like sharing data as available supplemental material, or maybe just throwing one data set out there. And that's a signal that, sure, they did okay, but they haven't really engaged with the process of making this research as robust as possible. And over here on the right, there are researchers that really embrace the sunshine, that use the research article as an opportunity to convince you that they have done some really great work. And they share their data sets, their code objects. It's likely reproducible. And this is the kind of research that can really be relied upon, because the authors have thought about it really hard and they want to convince you that they did a good job. And this, underneath here, you can see that this really comes through with how well they've done around open science. Anyway, so I'll stop there. This is what DataSeer is trying to do.
So yeah, thanks everyone for going over what y'all do. I'll go ahead and just talk briefly here about Scite. So Scite, we were founded in 2018. Multiple awards, all sorts of fancy stuff like that. Now part of the Research Solutions family. Very happy to be with them now. And we were originally founded around basically the idea of curating the text of citations. So we use natural language processing and AI. Actually, it seems like a long time ago now. It was, gosh, 7 years ago, eons in AI land. But we were using deep learning algorithms to basically classify citations. So you have one paper cites another. Well, what did they say about that paper? And we can classify those into a supporting statement. We replicated these findings, a contrasting statement, we failed to replicate these findings, or just a mentioning statement. And so being able to, sort of see all of that information in one place when you're looking at an article was really our first mission. And from there, we built out additional features that really take advantage of the landscape and combining it with our data. So we have a very powerful discovery tool with search abilities, as well as an AI tool, a text generative AI tool that uses the large language model technology that so many of us are now familiar with, but combines that with our data to give you actually a really reliable tool that is getting answers from scholarly research, as opposed to some of the out-of-the-box large language models, which can suffer from poor reliability in that regard. Yeah, perfect. Thank you. Yes. So this is has allowed us to address a number of challenges, and we're listing 3 here. I think these are 3 good ones to highlight, but there are others that I won't go into, at least at the moment. Just starting with fragmented access. So we have access to both closed access and open access sources, the full text of those papers. And that's really unique in this space. Most providers rely on abstracts or open access papers, or they're working specifically with one publisher. We are publisher agnostic at Scite. We have indexing agreements with major publishers from around the world. And what this is going to help you do is collate all those what we call citation statements. So what one paper says about another, really present them in one place, and really give a much clearer picture of where the research on that topic stands at any given moment. Probably the one that's most important to me, not just as a startup co-founder, but also as a researcher, as a university professor, is dealing with information overload. So really leveraging those citations to better understand what's going on, before I teach a seminar or before I, reference a paper in a paper that I'm writing, I'll often pull up the citation report for that paper, just to see what people have said about that paper. Maybe this paper that I'm assigning in a seminar has been, not refuted, but strongly contrasted by subsequent publications. I want to know that before I go talk about it, either in my writing or in my teaching or in my own research. So that allows you to really prioritize certain papers over others, and to really understand in a sort of global sense where one paper sits relative to the incredible number of papers that are published every year, as we saw Sharon went over with that slide earlier. And then, in terms of research integrity and reproducibility, we do a lot at Scite to really surface important information about papers. One project that I've worked on has been really surfacing notices, information about retractions, self-citations to papers. And we also, with our AI tool, Scite Assistant, we're really using our data to compose and answer questions and compose natural language answers to questions that are based on real research. So we're prioritizing, what we are trying to make is an ethical and effective AI tool that's really designed to aid in the research process. And trying to really, as a professor, teach my students to use it, trying to really figure out, sort of navigate those waters and figure out the best way to approach this new technology from a research standpoint. I'll stop talking now. Yeah.
Thanks, Sean. Just to, I guess, pull those threads together for everyone, and one of the kind of inspirations for bringing the webinar and speakers together was, if we can imagine a world where a lot of the fraudulent work, a majority of it is stopped at submission stage, and best practices set in, there are transparent research sort of excellence being carried out, and ways to identify which research you want to be reading at the right time, at the right place. But just taking a step back a little bit for Adam, Tim, and Sean, where do you see where AI is, helping and supporting versus really still needs, human support, human decision, connecting. You're all working slightly differently with AI technologies. And Adam, I'll ask you this first, because I know when you're talking about integrity and people's careers, you perhaps have a different view maybe than Tim and everybody, but.
Yeah, it's an interesting question. So where is AI supporting things? Well, I think that probably the easiest way to look at it is that, like many pieces of technology, like many new technological advances, it's making things faster. So writing can be faster. Finding the right research paper can be faster. And that is great. But the flip side, of course, is that the bad stuff can be faster too. Fabricating fake data is faster. Writing a fake paper is faster. I think that the thing that I like to think about a lot is about, on the one hand, we've got fraudulent practices, we've got bad behavior. On the other hand, we've got dishonesty. And so we have the tools that can make the bad behavior and the signs of that, the outputs come out faster. But it doesn't mean that there's suddenly more dishonesty in the world. And we accept that there is some dishonesty in the world. But I don't think we should expect that AI somehow accelerates dishonesty. And I think that's a really important thing to remember, because by and large, the majority of science is done by people who really care about it and really care about doing things in a rigorous and ethical way. So the fact that the tools exist to do that more or worse doesn't necessarily mean that the amount of dishonesty is in any way going to change.
But you would, I think, always say if there's a claim about someone committing fraud, a human needs to verify that decision. It can't just be down to a computer to signal. It can be a lot of identity issues, right?
I think that's absolutely fundamental. But I say that also applies to the whole of science. Is that science is, people often think about science as being, it's all rigor, it's all numbers, it's all very objective. And I would argue that science is absolutely not. Science is absolutely subjective, and people have got to care about it for it to be important. And the way where this applies to sort of the research fraud area is very much what you say. It's that you can have all these tools that will give you that data, and they'll give you all these objective insights into a piece of research. But what they will not do is give you a judgment over whether that research is fraudulent or not. And that part has to come down to the human. And I know I said this before in a lot of places, but I think even if we did have some AI that could do that perfectly and absolutely perfectly say this is fraudulent and this is not fraudulent, to automate that process of judgment, I think would still be unethical. It would still be wrong to allow a machine to make those judgments. And so there are two sides to it. One is about the practicalities of doing the investigations, making those judgments, but the other side is about the ethics. And we shouldn't just let AI run away and automatically make judgments about people. I think that's wrong.
Yeah.
What would be some signals for fraudulent work?
So there are a few, and what I look at is mostly at where things happen at scale. And that means that we'll see a pattern that is consistent over a huge number of papers. So you might have, say, 1,000 papers that people have, human beings have manually gone and looked at them, and they've said, okay, these have all of these problems that we judge are signs of fraud. So when you have a data set that big, you can say, okay, well, what features do all these papers have? And how are these features different to other papers in the world? And if there's something that really stands out about those papers, that's a sign that this is part of that same program of producing fraudulent research. But that in itself is not evidence of fraud. And that's the important part. The important part is that the human still has to go and look at it and make that judgment.
Tim, what's your sort of perspective on that sort of use of AI in humans? And I know you've been doing some great work and technical advances, and certainly in areas like Parkinson's research, I think there's some really good models that you're doing. But any sort of high level thoughts there based on what Adam said, and then we'll come to Sean too.
I love Adam's point about that there's maybe not more dishonesty in the world. I remember when I was living in Edinburgh, the police put out this piece of information. I don't know if they really meant to let this slip, but they said, you know, there's been a spate of house break-ins throughout Edinburgh in the last 2 years, but 70% of them are by the same 5 people. So that there are some people who are utterly terrible, and they account for a massive amount of the problems and dishonesty that's going on, because and AI is going to super empower these people to do a huge amount of damage very quickly. And it may be that there's only 100 of them rather than millions and millions, but they still can flood the literature with utter garbage at a high rate because it's so easy to produce fake research now. So the problem is sort of going to get superpowered over the next few years. I have quite a bit more hope about this. I think most research is the sort of bottom left of that axis of the very bad research and the kind of irrelevant and boring research. That's not really what drives progress. It's the top right. It's the new ideas. It's the powerful demonstrations that a particular phenomenon occurs or doesn't occur. And much of the rest of it is less important. It's not holding up the wall of, we're building a wall of scientific understanding and trying to stand on the top of it whilst we build it. And a lot of those pieces are not, a lot of those little research articles are not being incorporated into that wall. The problem is when the big bricks turn out to be fake and then the wall starts to crumble. So overall, the AI, the ability to make bad research is going to increase, like Adam says, and we need to be constantly updating how we're detecting that, and it's going to be an arms race that's going to continue. There's no end to it. But on the other side, science, this volume problem, there is a whole new class of reader in town. And I think we need to really embrace this idea that AIs are going to be the biggest reader of scientific articles, and they will read everything. And we need to give them tools for making decisions about whether research is worth incorporating into their understanding or not, or how much weight to put on a piece of research based on how trustworthy it is. Did the researchers really go out of their way to prove their point, or is this just the bare minimum? Is it salami sliced? Is it fraudulent? And so it may be that journals switch to having subscription, go back to a hybrid model where all the articles are open access to human readers, but that's subscription only for the enhanced data plus code plus full body of evidence for the AI readers. And because right now, feeding an article just the words, just taking the words and putting them into an AI doesn't give it enough information about the robustness of that work. They need to be able to assess the underlying data sets and the code and join that all together to come up with a proper understanding of how the strength of the evidence in the article itself.
That seems like a good segue for Sean and the classroom and Scite and thoughts what you're seeing on the ground there, Sean.
Yeah, I mean, I guess so. Not wanting to lose track of the original question, which I guess just having to do with sort of the ethical nature of this. And I want to start out by saying I also am in violent agreement with everything Adam said and everything that Tim said. I think that you know, there's not more dishonesty necessarily in the world. It's just that it's easier for the people who are already dishonest to sort of exponentiate their dishonesty, right? One thing that I think we also need to consider is the fact that we're bad at catching fraud. And this is coming at things from sort of a forensic meta science perspective. How do you catch the bad actors? And in fact, the instances that I'm most familiar with in my field of social psychology, these are instances of fraud where people just were not good at doing fraud. And so I'm actually quite hopeful that some of these new tools, and this is we're a little ways away from this, kind of building on what Tim was saying about combining the text with also data and code. I do have kind of this idea that we might at some point in the future be able to unleash this technology to identify patterns that are indicative of fraud or lesser cases of misconduct. Now, all of that is sort of from the research standpoint, from a sort of meta science standpoint. And that's going to require buy-in from publishers, from researchers themselves, from academic institutions. But I think there is a future there. From the classroom standpoint, I will just tell you that I just assume that every one of my students uses text generative AI in their assignments. I think it's probably, what's the best word for this? I think it's probably not appropriate to assume that you can tell them not to. The technology is just too good not to use. And so, what I, my own personal opinion is that, in the academy, our mandate is to do right by our students. We need to equip them to understand how to use this technology and use it effectively and ethically and in ways that actually make them better at what they do, both in and out of the classroom, rather than worse. And that's going to require a lot of changes, on the part of professors like me. I mean, I don't really give term paper assignments anymore because I know how those papers are going to be written, and it's not doing the job that they did, 10 years ago or 20 years ago when I was in college. So, a lot of this just means that we're going to have to think about doing our own jobs differently. And that's just the result of technological progress en masse, right?
Now we've heard from all of our experts now. Let's ask the audience and really start stargazing. Give us some of your questions. What are you interested in hearing about the future of AI as it relates to research output, trust in science, how it affects the ethics of research? We'd love to hear some of your questions as we move on to the next topic. Speaking of trust in science, we can start addressing some of those issues. I think you mentioned this a bit already, Adam, but the warning signs of unethical research practices and how we can identify that earlier in the process so we don't have to have retractions.
Well, there are a few things, and I would say that if we're thinking upstream as far as possible, I always say this thing about people getting into data analysis. It's number one, don't fix the data. Number one is produce good quality data in the first place, so that you don't have to fix the data. And that's really important because rule number two is get really good at fixing data, because you're going to have to fix data if you are working with data. And that's sometimes the majority of the work. But it's about looking at that data early on and having as much of it as possible. And a really good example is how much history does someone have? And so if somebody's got a really well-documented history with good identifiers, like, for example, ORCID, they put ORCID on every single thing they've published. And there are no issues in there. We've got 100 papers from an author, and none of them have ever been flagged for anything that looks like fraud. Well, that's really good. That is somebody who's probably very trustworthy. If you have an author, though, who's got 10 papers, all of which have been flagged for fraud, and they're submitting a paper, well, we don't have to really do analysis at that point. At that point, we could say, okay, there's a history here, and I would still argue that a human being needs to make a judgment on that. They can't just assume that this means that this person is bad. But I would say we want to see things as early as possible. We want things as far upstream as possible. But number one, that is about data quality and quantity. You know, having everything there in good quality is really critical. But also accepting that even if that's the case, it's still going to be a ton of work for people like me.
Should we be scanning preprints?
Well, we are. Yeah, funnily enough, paper mills, big factories putting out fraudulent research, their goal is to get papers published and get that onto someone's CV, and that's what they sell. But weirdly, we see preprints coming out from there. And at first I thought that was bizarre. I thought, oh, I must have made a mistake because that doesn't make any sense. But I thought about it. I thought, well, first of all, that's still a line on the CV. A preprint is still a line on the CV. So it's something that they probably can sell. But secondly, some journals mandate that. They mandate, an open access journal might mandate that something gets preprinted. So in the process of getting that output for their customer, they will end up hitting a preprint server as well. And preprint servers are in a very different position to publishers in that they're usually working on much tighter budgets, and they're intentionally not reviewing stuff. So they shouldn't necessarily be detecting fraud. And so, yeah, it's a different sort of environment, ecosystem that they have to think about.
Well,
would it be appropriate?
So just add, especially Adam, if the AI kind of crawling agents are kind of scanning and technically could be rating the info in a preprint the same as a peer-reviewed article with 1,000 citations, like that waiting, because things are done in a black box. I think there could be better systems there, but Sean, were you going to say something on that, Sean? I'm keen actually to go back to your point, Sean, about things are changing in academia, and it feels like there is going to be a big change upon us, but also sort of some things within scholarly communications, publishing, research assessment don't change that quickly. So how do we sort of balance that desire to change and the innovation with the kind of system that doesn't always have inertia to change?
Yeah, I mean, I think that the rapid adoption of these technologies are going to kind of force the hand of some, institutions that don't move terribly quickly, just in their own disposition. I mean, it's just kind of going back to what I was saying earlier. If professors want to continue to assign term papers in the future, I mean, they're going to get a lot of AI generated stuff. And institutions, and they're going to have to decide, is this actually doing what I need it to do? Similarly, institutions, we're rapidly approaching a point where it's a lot easier to get stuff published, not just from the standpoint of journals. There are journals with more lax standards regarding peer review, and also it's easier to write stuff with the AI tools. And so, my own department, like most universities, has publishing requirements. You have to get X number of papers in such and such journals over this period of time if you want tenure and promotion. It might be time to rethink that too. And the existence of the ability to sort of churn out AI generated stuff might force the hand in that way. Yeah, Tim, go for it. Or unless somebody else wants. Yeah.
Wanted to add that you're actually hitting the nail on the head, that publication as a way of gatekeeping career advancement, particularly when the people themselves aren't actually researchers. For example, doctors requiring publications to get residency and so on. That's just an absolute invitation to research fraud. You've got no time. You're trying to qualify as a doctor. Now you have to come up with some research, conduct it, write it up, and publish it. And nobody's really going to care about the research either. It's just performative that you have to do. That's a recipe for fraud. And and it's understandable that they would do that because it's it's not part of their job to do good research. It's part of their job to be a doctor. And so it's pointless getting them to do research on the side as a sort
Yeah.
of way of demonstrating.
I think you're sort of making a counterpoint though to the honesty point, which is that where you have honest people who are required to do things that are really outside of their reasonable expectations. I think that's also a recipe for dishonesty, and that the people will sort of feel like, oh, I'm being told I have to publish a paper. That is not my job. However, I have to do it. Therefore, I will pay someone to do it for me. Yeah, I worry about that maybe as a trend where it sort of affects honesty, because you end up with people who aren't actually researchers. They aren't actually scientists who are being sort of pushed into the sphere of doing research and doing science, and they have no choice but to do these things.
Yeah. We have a couple of questions now coming in from the audience. Thanks, and keep them coming. There's quite a big one, a meaty one about how would you avoid influence by leading AI firms, e.g. putting biases in code that would endanger scientific rigor of future AI research tools? Anyone feel like taking that? Like, there's obviously a potential big influence and sway of big tech, but having some underlying kind of AI ethics and morale we're all working to, right? Yeah.
My take here is that it's research articles are going to get ingested one way or another by AI companies. What we need to do is give the AI a means to understand the validity of that research, rather than sort of gatekeeping what can be added. We need to give the AI a way to understand it. Right now, the AI is ingesting vast amounts of research to generate a very accurate model of what kind of words follow what other words, which is what a large language model is. It's an incredibly powerful tool for predicting the most likely, the most probable next word in a sentence. So it doesn't inherently understand anything, but it looks like it does in an incredibly impressive way. And that's going to change dramatically as we move to agentive AI in the next 3 or 4 years. And these are sort of like little fleets of AIs that all work together, and some tackle one task, some tackle the other, and they bring things together in a sort of form of understanding and accomplish big tasks together. So I can see that editorial offices, for example, will become almost completely automated in a few years. And we need to be ready for that. And things that we haven't imagined yet will become completely automated as a way of cutting costs on the publisher side. Anyway, to someone else.
Just to add a comment to that, and to the question we had from the audience, I do think some of the bigger industry boards and organizations, the STM associations, other are aiming to have that sort of dialogue with the sort of big tech companies and come together as a community, but it'll be interesting to see where those go. Did anyone want to add anything to that, or shall we move on to the next question?
I think there's just a point that goes back to what Tim said earlier about, writing for AI, writing for the machines, which I think is something that's probably been good advice for a while now, that machines probably read papers more than humans do. And I think that when you have bias in AI models, one point to make is that a lot of the time that is measurable, and it is something that the people making those models will measure and will account for. And also when they rebuild, retrain, and change their methods, some of those biases will shift around. So it sort of comes out in the wash if there is a problem that maybe can't be seen. But that being said, those problems often can't be seen in the applications when people are using the tools. They won't be able to see some little bias that has crept in because of the way that something has been trained. And I think that is a problem that exists now that will continue to affect things in the future. Another problem that might be related would be things like hallucination in generative AI models, because a lot of the time I'm writing and Copilot will say, okay, here's what you're going to write next. And I'll look at it and go, no, that's actually better than what I was going to write. And so you sort of use what it puts in, but if you skim read that and you miss that something was not right in the middle of what it said, that error could propagate out into the research literature, into people's brains and other literature, other research, without anyone knowing or intending any harm. And I think that's a really big problem that we're going to see. But I'm more concerned that we're not going to see it, that it's going to be hidden from us, and we're just going to have to accept that will happen.
Yeah.
We need to.
There's another question on the in the Q&A about whether you include predatory journals in your scanning. I mean, now we're looking at really individual research papers. I think some journals, I don't know if the term predatory journal is even used today, because we're all getting so granular at the manuscript level. And as it relates to that, someone wrote in the chat, what is preventing an LLM from becoming a repository of false research? And I would say all the tools, I would say Clear Skies and DataSeer and Scite are working to prevent that. But I'd like your feedback.
Could I maybe make a point about that, which is about so LLMs are trying to model language, and part of language is lies. Right? There's the truth and there's lies and there's falsehoods, and all of that is still language. So the truth that LLMs are trying to learn is about how language works, and that includes learning how lies work and how the truth works. So actually, it's not invalid for them to train on that data. The point is that there also needs to be something which is telling the difference between the truth and the lies, and telling the difference between good science and bad science, and that's everyone. Well, that's the whole scientific community. Publishers, yes, of course, to some extent, but also researchers themselves, institutions, funders. Everyone has to put in something to answer those questions. But so actually, in some ways, I don't have a problem with an LLM being trained on fake or fraudulent science. I have a problem with the way that it might be used, which would cause more fraudulent science in the future. And I think that's an important distinction, that we actually can accept that there will be problematic content going into LLMs, and that itself isn't a problem. That the problem is what comes out and how it gets used.
Just jumping off of that, if you don't mind, real quick, two things I think Adam brings up really important, sort of going off of that. So I think one thing that we've done at Scite is we've actually split up the process. We have one sort of process with our assistant, our text generative AI tool, that's all about sort of generating the text of the answer. It's like the reading and writing part of the task. But we have a completely separate system for actually searching for articles. And with the standard large language model just out of the box, it's doing both the fact finding and the reading and writing kind of all in one. And I think that figuring out, designing different systems for fact finding than for reading and writing using the same technology is one useful paradigm, one useful way of moving forward with this, because they are very different tasks. Like as Adam said, people lie, and that's that's part of reading, right? Is recognizing that people lie, but your fact finding shouldn't be doing that. The other part about that is that we actually do have some systems in place, and I think that you'll see this adopted more widely, that do look at, we have some internal lists of publications or stuff that we basically don't want to show up in our product, don't want it to be highlighted, and the system just downranks all those into oblivion, so you never see them. I think those kinds of quality controls are going to be really important, and you'll start to see a lot more of that.
Yeah. We have a question also about what's the role of metadata in an AI world, and perhaps a little context to that too. I guess there are a number of potentially older articles, metadata describing whether it be a grant or a publication or a preprint, But as sort of metadata has improved over time and may have links to data and data sets and data citations, is there a role where AI perhaps needs to clean up some historic metadata, or how do you view metadata versus the full published content of things? Do you, Adam, do you get nearly as many insights?
It's both. I mean, metadata is incredibly important, and it's most of what we do right now is on metadata, but full text is also critical. And it's sort of one of those other points about good luck, which is that not only do we have this brilliant network data going back centuries, we also have the only system, the only industry where if somebody commits fraud, they have to publish evidence of what they've done. I mean, that's amazing. Like, that's incredibly good luck if you want to get into fraud detection and you're in a situation where that's the case. So that's in the full text, and so there's huge value in modeling that and understanding it, and actually also in, again, fixing the data, because actually full text data has all kinds of issues. Yeah, which is more important? I would say they're probably both equally important. I would maybe put metadata up higher, because that's really where all the network stuff comes in, and as I say, I think that's fundamental.
I think around this point that one of the unappreciated powers of LLMs is that they're able to do simple tasks really, really, really well. And a big part of what we're working on at DataSeer is to get the power of an LLM and use it to make fairly simple judgments about text. And so one thing is thinking about who funded this article, and if there's initials in it or something like that, then we can use these agentive AIs to say, well, there was a different article published by these same authors that lists this grant number, and it looks like the same subject, so it's probably the same grant number again. And that's a fairly simple chain of reasoning, but it does mean that we can then put this potential metadata. It's not 100% sure, or we can bring it to the author and say, is this a grant number you should have put into this article? And so a human can do that, but not for 4 million plus articles a year, not for the huge number of articles in the back catalog, but an AI can. And citations, the difference between citations, which is this, like Adam says, it's incredibly robust, well curated network between articles. When you go out to, well, data sets, so an article reused the data set, the citation happens maybe 10% of the time. Sometimes they mention it just in passing, sometimes they give an acronym, sometimes they talk about the paper that originally published the article, published the data set. And so that citation doesn't exist in the same formal way. And AI is able to pick out those instances of data reuse and create a putative citation from that. We're not going to be able to change author behavior so that they start citing data all the time unless publishers really crack down on that. What we are going to be able to do is reconstruct from what authors have said they did into what looks like a citation.
In fact, yeah, actually, just building off of that, I know folks at OpenAlex, if people are familiar, who are actually building tools that augment existing metadata with new information, like tracking authors from institution to different institution. They're already kind of doing that. So I think this is already going on. It's interesting.
Good. We're coming up for like 6 minutes left, so it's perhaps a good time to do a little more future stargazing for you guys. I know you've had a lot of thoughts, but interested to sort of see and talk about where we are now. But how do you see the future? Are we, certainly one thing on my mind, like AI is also progressing quickly. There's talk of super AI and things it can do, but where do you see we are now and maybe going to be in the next 3 to 5 years? Is research going to change drastically? Are publishers going to change, or are we just going to get better at doing things? where are you all seeing? Tim, you have your hand up, I think. So you want to go first?
I do. I wanted to go 10 years into the future. I think research funding budgets are going to be dramatically cut. I think governments will ask themselves, the AIs are doing a pretty good job by themselves. So why do we need all these researchers producing all this mediocre to useless research? How are they helping us? And they may be tempted to just cut a lot of the poor or low quality research out. I don't want to say whether that's going to be a mistake or not a mistake, but I think given that governments like to cut money where they can, that may be something that they home in on, because it becomes apparent that you don't need humans to do research anymore.
But I would just argue that point. If you look at sort of countries like China that have invested in an R&D infrastructure, more and more universities, contents changing from a manufacturing economy to a knowledge economy. Also, you have to kind of invest in the teaching, and not to say that teaching isn't going to be very different and what inspires the kind of young up and coming researchers, but Sean, perhaps you want to pick up on Tim's point or other points.
Yeah, I was just going to say, as a social scientist, Tim's talking about low quality research. I feel seen. But no, I mean, I think that's a definite. I don't know that I think that's definitely where it was going, but I can see that as a possibility. I think one thing that occurs to me is perhaps we need to think about the way that we do sort of assessment in gosh, go back to orals. I think someone had in as a question, I can't find it right now, but maybe oral defenses and oral exams become a thing again. Simply because you can't, sort of substituting for what you would normally want someone to do with a paper. Maybe yeah, you do see, you just I think this will become part of the infrastructure of the research process. You will be reading grant applications that were written with AI. You will have to learn to live with that, and we will have to learn to tell the difference between a grant application or a paper that was written that was just copied and pasted directly from the AI tool, which is not the way to do it, versus the application or the paper that was written where someone was interactively using the AI tool and was saying, hey, find me research on this, and then they're rephrasing things and they're moving stuff around and they're thinking carefully about what it's saying. I think we will learn to discern one of those instances from the other, hopefully, and that will probably be in an increasing amount of sort of the human element there.
Yeah,
I just thinking about what Sharon's point at the start about doubling every 9 years, and you can see that you can draw a graph going all the way back about 80 years, where we started getting this geometric growth in science, and it's kept going until now. And it's like we're talking about technology that will accelerate things. Well, surely this is going to accelerate, and we're going to see even more stuff coming out, and that's a realistic expectation. At the same time, I don't hear people saying, "Oh, we need so many more papers. It would be great if there were just more papers." Like even publishers who profit from papers, no one got into publishing thinking, I'd love to publish tons of low quality science. People want to publish good quality science. People want to write good quality science and do good quality research. And I think that there's a risk of the whole reputation of science and of research and of journal brands, for example, being put at risk because of the amount of problematic content, not just the fraudulent stuff, but also just the low quality stuff. And that's been, I think, a risk for a while now. I do think there are opportunities for people who are going to focus really hard on high quality science and not publishing bad science. Publishers, going into that space, I think there is an opportunity there. And I'd like to think about a future that's much more focused on quality than it is on quantity, especially compared to how it is now. I don't know how realistic that is, but I do like that future. What I will say is that, you know, we're seeing better quality science in the literature. I can pretty much guarantee now that there are going to be better quality fraud as well. And that's the future that I'm preparing for. It's about how do we get better quality tools for detecting this better quality problematic content that we're going to see in the future, that we're definitely going to see.
Yeah, I know we're up for time. We could have probably taken another hour of everyone's time. We didn't get into topics. I wanted to talk about things like knowledge transfer from all this research too. But I want to thank the audience for here. This will be recorded, right, Julia? You know, hopefully we've kind of left you with a few things to think about and perhaps even more questions. So do get in touch with any of us on here if you know, your thoughts or insights, or it's inspired you. Sharon, Julia, do you want to say anything else in closing? Again, a huge thanks to everyone who joined and for all the speakers here.
Certainly. Thank you so much, everyone, for taking the time to join. We do hope you walk out of this webinar feeling inspired and maybe just some new thoughts in your mind. I did add links to DataSeer, Clear Skies, and Scite if you want to head over there. And of course, here on this on the slide, you can also see email addresses if you want to get in touch with either of us afterward. Thank you so much to all of you for attending, all of you for speaking and presenting and sharing your viewpoints. And yeah, have a great rest of your day, everyone.
Thanks, y'all.
Thank you.
Thanks, everyone. Okay.